Let's now consolidate.
So that was our use strict question to person. Let's see function. First name underscore second name underscore birds right. So whenever we do let's say the constraints, when you say the new keyword, it's gonna do four things. The first thing is that
the knowledge that we got over the last 2 videos in a nice diagram that brings everything together that we know so far. And everything starts with the person constructor function that we've been developing. Now, this constructor function has a prototype property, which is an object, and inside that object, we defined the calcH method. And person.prototype itself actually also has a reference back to person, which is the constructor property. So essentially, person.prototype.constructor is going to point back to person itself. Prototype.constructor is going to point back to person itself. Now remember, person.prototype is actually not the prototype of person, but of all the objects that are created through the person function. And speaking of the created objects, let's now actually analyze how an object is created using the new operator and the constructor function. So when we call a function, any function, with the new operator, the first thing that's going to happen is that a new empty object is created instantly. Then the this keyword in the function call is set to the newly created object. So inside the function's execution context, this is now the new empty object. And that's why in the function's code, we set the name and birth year properties on the this keyword, because doing so will ultimately set them on the new object. So next comes the magical step. So now the new object is linked to the constructor function's prototype property. So in this case, person.prototype. And this happens internally by adding the __proto property to the new object. So person.prototype is now the new object's prototype, which is denoted in the __proto property of Jonas. So again, _proto always points to an object's prototype, and that is true for all objects in JavaScript. Great, and finally, the new object is automatically returned from the function unless we explicitly return something else. But in a constructor function like person, we usually never do that. Okay, and with this, the result of the new operator and the person constructor function is a new object that we just created programmatically, and that is now stored in the Jonas variable. And this whole process that I just explained is how it works with function constructors and also with ES6 classes, but not with the object.create syntax that we're going to use later. So just keep this in mind once we reach the object.create lectures. But anyway, why does this work this way, and why is this technique so powerful and useful? And to answer that, let's move on to the next line of code. So here we are attempting to call the calcH function on the Jonas object. However, JavaScript can actually not find the calcH function directly in the Jonas object, right? It is simply not there. And we already observed this behavior in the last lecture. Remember that? So what happens now in this situation? Well, if a property or a method cannot be found in a certain object, JavaScript will look into its prototype. And there it is. So there is the calcH function that we were looking for. And so JavaScript will simply use this one. That's how the calcH function can run correctly and return a result. And the behavior that we just described is what we already called prototypal inheritance or delegation. So the Jonas object inherited the calcH method from its prototype. Or in other words, it delegated the calcH functionality to its prototype. Now the beauty of this is that we can create as many person objects as we like, and all of them will then inherit this method. So we can call this calcH method on all the person objects without the method being directly attached to all the objects themselves. And this is essential for code performance. Just imagine that we had 1,000 objects in the code, and if all of them would have to carry the calcH function around, then that would certainly impact performance. So instead, they can all simply use the calcH function from their common prototype. Okay? So that makes sense, right? Now, the fact that Jonas is connected to a prototype and the ability of looking up methods and properties in a prototype is what we call the prototype chain. So the Jonas object and its prototype basically form a prototype chain. But actually, the prototype chain does not end here. So let's understand the prototype chain a bit better by zooming out and looking at the whole picture. So here is the diagram that we already had with the person function constructor and its prototype property, and the Jonas object linked to its prototype via the _proto property. So nothing new yet. But now let's remember that person.prototype itself is also an object. And all objects in JavaScript have a prototype, right? Therefore, person.prototype itself must also have a prototype. And the prototype of person.prototype is object.prototype. Why is that? Well, person.prototype is just a simple object, which means that it has been built by the built-in object constructor function. And this is actually the function that is called behind the scenes whenever we create an object literal. So just an object simply with curly braces. So essentially, the curly braces are just like a shortcut to writing new object. Okay? But anyway, what matters here is that person.prototype itself needs to have a prototype. And since it has been created by the object constructor function, its prototype is going to be object.prototype. It's the same logic as with the Jonas object. So since Jonas has been built by person, person.prototype is the prototype of Jonas. Alright? Now this entire series of links between the objects is what is called the prototype chain. And object.prototype is usually the top of the prototype chain, which means that its prototype is null. So its _proto property will simply point to null, which then marks the... Now this entire... series of links between the objects, it has been built by person, person.prototype is the prototype of Jonas. Alright? Now this entire series of links between the objects is what is called the prototype chain. And object.prototype is usually the top of the prototype chain, which means that its prototype is null. So its _proto property will simply point to null, which then marks the end of the prototype chain. So in a certain way, the prototype chain is very similar to the scope chain, but with prototypes. So in the scope chain, whenever JavaScript can find a certain variable in a certain scope, it looks up into the next scope in the scope chain and tries to find the variable there. On the other hand, in the prototype chain, whenever JavaScript can find a certain property or method in a certain object, it's going to look up into the next prototype in the prototype chain and see if it can find it there. Okay? So again, the prototype chain is pretty similar to the scope chain, but instead of working with scopes, it works with properties and methods in objects. Alright? And now let's actually see another example of a method lookup. To do that, we call the hasOwnProperty method on the Jonas object. So just like in the previous slide, JavaScript is going to start by trying to find the called method on the object itself. But of course, it can't find the hasOwnProperty method on Jonas. So according to how the prototype chain works, it will then look into its prototype, which is person.prototype. Now, we didn't define any hasOwnProperty method there either, and so JavaScript is not going to find it there. And so, therefore, it will move up even further in the prototype chain and now look into object.prototype. And object.prototype does actually contain a bunch of built-in methods, and hasOwnProperty is one of them. Great. So JavaScript can then take this one and run it on the Jonas object, as if hasOwnProperty had been defined directly on Jonas. And remember, the method has not been copied to the Jonas object. Instead, it simply inherited the method from object.prototype through the prototype chain. Okay, and that's actually it. That's all I have to tell you at this point. So this is, in a nutshell, the magic of prototypes and the prototype chain. And this will actually become even more interesting and useful once we add inheritance between two different kinds of objects, or two different classes, so to say. For example, having a student class inherit from a person class, just like we learned in one of the 4 pillars of OOP. Remember? So there is a lot of exciting stuff ahead, and so let's move on. Let's now check out prototypal inheritance and the prototype chain on built-in. In objects such as arrays. But actually, let's start this lecture by inspecting some of the stuff that we just talked about in the last lecture. And we will keep using this person example that we have been building. So let's start by taking a look at Jonas.__proto. And we already know that this is the prototype of Jonas, which is exactly the prototype property of person. And so therefore, it is this object which will appear. But now let's add the prototype of Jonas's prototype. The prototype property of object. So that's why you can see that this method. And so this property on Jonas. So again, we learned in the last lecture, because this method here is in this prototype of Jonas's prototype. And so, yeah, that's this object that we are inspecting right now. All right. Okay, but let's take this one step further and check out the prototype of the prototype of the prototype. Yeah. And do you remember what this one is? That's right, it is null. And so that's because object.prototype is usually the top of the scope chain. So this one here, right? So this one is going to be object.prototype. And so that's the top of the prototype chain. Okay. Now we can also take a look at that strange constructor property that we also saw earlier. So remember, person.prototype itself has a constructor property, which, as we said, will point back to the person itself. So constructor like this. And so here we actually get the function itself. Now if we want to inspect that function, here we need to use console.dir. And so here indeed, we see that the constructor property points back at person. So that's this. Now to make things a bit more complicated even, let's now take a look at the prototype of a function. So any function, of course, is also an object, and so therefore it also has a prototype. But maybe this is a bit too confusing, so let's just leave it here. So I will first show you the prototype of arrays, and maybe then we can move a bit further to functions. So actually, let's do that now. So let's create an array, just like with any random numbers. So the values here, to take a look at the... So let's see, and here it is. So this is the prototype of array, and you see that here we have all these methods that we already know. So we have fill, we have filter, find, earlier sections, these methods. But instead, all right, exactly. So one more time, the prototype property of created by indeed. And just like in objects, using this shorthand, basically, for whenever we create an array like this, it is indeed created by the... But of course, this is not yet the end of the prototype chain, as we saw. Let's see. And so now we are back to having object.prototype. You see? So this again now has own property, and then all of these methods here that are available. Prototype itself here is methods. Also directly in and OP right here. So that we on MD. You see that actually the name of the method is array.prototype.filter. And that is because this filter method does, of course, live in the prototype property. So one more time, you can see that the prototype inheritance is really a mechanism for reusing code. So all of these built-in methods here have to exist only once somewhere in the JavaScript engine, and then all the arrays in our code get access to the functions through the prototype chain and take this one step further methods from its prototype. And therefore, we can use that. So all we would have to do is to say array.prototype, and then here we can add any new method to this prototype, and all the arrays will then inherit it. So let's say that we wanted to create a method which returns all the unique elements of an array. So let's add a method called unique. So we set the unique property to a function, and then to get the unique values of an array, all we have to do is to create a new set and pass the array in there. And the this keyword is going to be the array on which this method will be called. And so now we just need to put this into an array. And so we can now use that. So array.unique, and we don't have a lot of duplicates here. Let's add another 6 here, and maybe another 9. Beautiful. So just to recap, we added a new method to the prototype property of the array constructor. And so therefore, now all arrays will inherit this method. And so we can then call that method on any array that we want. However, what we just did here, so extending the prototype of a built-in object, is generally not a good idea. I mean, if you're working just on a, don't get in the next version of JavaScript, this one here, use that new method, which remember works differently, and then that will probably break your code. And the second, then this is really going to be a different name than because you should probably not do it. Now, for a little bit of fun, to finish this video, let's take a look at some more built-in objects here in the console. So, for example, we can select this DOM element here. And so, let's do that, this h1, behind the scenes up. Right, so let's try console.dir on this h1. And so now we get the actual object. So here we have all this different stuff and all these properties and methods that we already work with. But what I'm interested in here is the prototype. And you see that the prototype is an HTML heading element. All right, and so that itself will contain a lot of different stuff one more time. So let's scroll all the way down. And so this is now an HTML element. And do you remember these names here from somewhere? Well, these are exactly the types of objects that we talked about in one of the first lectures in the DOM section. Remember that? So we had this big diagram with all these different types of elements. And so now here we can actually inspect them. And so behind the scenes, these different elements are really different, like constructor functions. So if we go down here, we should now see element. And indeed, here it is. And so again, you can recall that diagram that we inspected there, and then you will remember that HTML element was a child element of element, and element itself was a child of node, right? And so therefore the prototype of element is going to be node. So if we scroll all the way down here, then you see indeed node, and now this one is event target. And so you see this is a huge, huge prototype chain, and only now we are at the end, and so the end is then object, and that's it. So this prototype chain has easily 6 or 7 levels, and so you see that it can go really, really deep. So if you want to go and check this out by yourself, then that would probably be a really nice exercise. And finally, let's just also console.dir some random function. So the function doesn't matter. I just want to be able to look at the function. Okay, and so as I mentioned a bit earlier in this video, the function itself is also an object. And so therefore, it also has a prototype. And in this case, the prototype will then contain the methods that we have used previously on functions. So that's apply, bind, and call. Remember? And so once again, this is the reason why we can actually call methods on functions. It's because they are objects, and objects have prototypes. And in this case, this function prototype. So you can spend a lot more time if you're really interested in exploring all of this. But once you think you have a good understanding of all the previous lectures, then you can move on to the next video, which is going to be the first coding challenge of this section. So we learned how to implement your first coding challenge of this section. With constructor functions, it's time to finally put everything that we learned on constructor functions into prototype property. So in this section, I want to turn our constructor function in order to implement which essentially allow us to do the exact same thing. For this purpose, in JavaScript do not work like traditional classes in other languages like Java or C++. So instead, classes in JavaScript are just synthetic sugar over what we learned in the last few videos. So they still implement prototypal inheritance behind the scenes, but with a syntax that makes more sense to people coming from other programming languages. And so that was basically the goal of adding classes to JavaScript. But anyway, let's now implement person using a class. So we can write class, and then the name of the class. And let's actually call it person CL, so that stands for class, and then curly braces like this. And so this is actually a class declaration, but just like in functions, we also have class expressions. And so that would work like this. So class expression and class most class, okay, functions and class. Do is to add a constructor method. So just like this, and this constructor actually works in a pretty similar way as a constructor function, so as we studied previously, but this one is actually a method of this class. And in fact, it needs to be called constructor, so that is the rule. But just like in constructor functions, we pass in actuator. And this time let's create Jessica here. So new person CL, and so as you see, everything here looks exactly. And so just like before, we set the properties of the object like this. So this dot first name is equal to first name that we receive, and the same for the and so now it's time for the methods. And the methods we simply write like this. So we can simply add them here, and all we have to do is to write their name. So just like a regular function in here. So this is very nice and very convenient. And so let's simply do the same as before. So this dot birth here. Now what's important to understand here is that all of these methods that we write in the class, so outside of the constructor, will be on the prototype of the objects, and not on the objects themselves. So this is really just like before, prototypal inheritance. And in fact, we're going to be able to confirm that here. So as we inspect this Jessica object, when we look into its prototype, then we will once again see the calc h function here. All right? And so therefore, of course, we don't even need on its own. And so one more time, underscore pro to pert is true in constructor. We don't have to manually that's here. So intype it to the prototype property of the class, basically. So they will be added to the prototype. Take this to the prototype. So let's create a greet method here. So let's just say hey, and then the dot greet, it works just as well. It's really just so of course we could now do the same like this methods work the exact same way for people who are coming from another language and have experience with object-oriented programming, because it's going to be a bit easier for these developers. None of these you really true chains about classes that are important, not hoisted. And so even if they are class declarations, so function declarations, remember, are hoisted, which means we can use them before they are declared in the code. But with classes, that doesn't work. Second, just like functions, classes are also first-class citizens. First-class citizens. And so what that means is that we can pass them into functions and also return them from functions. And as I mentioned before, that is because classes are really just a special kind of function behind the scenes. And third, the body of a class is always executed in strict mode. Classes are executed in strict mode. And so even if we didn't activate it for our entire script, all the code that is. So keep these points in mind if you want to work with classes. So now at the end of this video, you might ask if you should use constructor functions like we have been doing, or if instead it's better to just use classes. And the first remark I want to do here is that constructor functions are not like old or deprecated syntax, so it's 100% fine to keep using them. So one more time, this is more a question of personal preference. Now, if you're asking if you should use classes without understanding prototypal inheritance, well then the reply that classes are really bad in general, the true nature of JavaScript. But I actually don't agree with that, and I think it's absolutely okay to use classes in your code as long as you understand everything that I just showed you previously about the prototype and prototypal inheritance. So you cannot just skip that part, because you want to become an expert in JavaScript, right? And you also want to feel comfortable while writing your code, and that essentially means to understand exactly what your code does. So that's super important too, and so if you want to be confident, you need to understand. And so that's also the whole reason why all over the course I'm going into such deep detail into how everything works in JavaScript. Now, what I personally like about classes is that they visually put all the code that belongs to a certain class, so like all the data here and all the behavior, all into one nice code log like this. Let's now talk about a feature that is actually common to all objects in JavaScript, and that's getters and setters. So every object in JavaScript can have setter and getter properties, and we call these special properties assessor properties, while the more normal properties are called data properties. So getters and setters are basically functions that get and set a value, so just as the name says, but on the outside they still look like regular properties. And so let's first take a look at getters and setters in a simple object literal, and for that I'm going to use the bank account example from the Bankist application. So, very simple object literal here. The owner is Jonas, then some simple movements, so the values here don't really matter, okay? Oh, and of course, I'm writing this object all wrong. Maybe you have already been noticing that. Okay, but now it should be correct. All right, but now to add a getter to this object, we can start by basically writing a normal method. So let's say that we want a method to get the latest movement, and so let's call it latest. And then to transform this into a getter, we simply prepend the keyword get. All right, and so let's simply return the last movement here. So that's this dot movements dot slice -1, But this is actually going to return an array, so an array with the last position. And so we can simply take that out using the pop method. And we could have used the structuring as well, but I didn't want to save this into an external variable first. And so now we can use this getter like this. So a count, and then we say latest, but we simply use it as a property. All right, so we don't call the method, but instead we write it as if it was just a property. So let's see, and indeed that returns 300. So this can be very useful when we want to read something as a property, but still need to do some calculations before. Okay, and now we can do the same also as a setter. So we say set latest again, and then here we can basically add a new movement to the array. And any setter method needs to have exactly one parameter. So in this case, that's simply a movement. So let's say this.movements.push, and then that movement that we just passed into. Now, it is not mandatory to specify a setter when we have a getter for the same property. Okay, so just a getter or just a setter would be enough. And so, how do we use the setter now? So if it was a regular method, then we would have to do this. So count.latest, and then call it with the movement, let's say 50. But now, this is actually like a property and not a method. And so, we can simply set it just like we set any other property. So we essentially set it equal to 50. And so now if we take a look at the movements here, it will then give us the complete array with the 50 there at the end. And so in a nutshell, this is how getters and setters work for any regular object in JavaScript. Now, however, classes do also have getters and setters, and they do indeed work in the exact same way. And so let's try them out now here in our person class. So here we can, for example, add a getter for the age property. So we can say get age, and then we return the age. So this is, of course, very similar to the calc age method that we already have here, but that doesn't matter because this is really just a demonstration example. All right, and so like this, we will be able to basically read the age of any object using a property. So let's try that here, for example, Jessica.age, and this time we actually need to log it to the console. And you see here, we now get the same value. All right, so you see that the getter is indeed just like any other regular method that we set on the prototype. And in fact, we can also check that out here. So if we take a look at the prototype of Jessica, it will be right there. Now it has these dots here because it's only calculated once we actually click this. Okay, so here too, it already looks as if it would be a property and not a method. We still have the get method down here, but then it's also kind of added as a property. All right, so that's a very simple use case of a getter, but setters and getters can actually be very useful for data validation. And as an example, let's try some validation with the name. So for that, I'll actually change first name here to full name. And so now here we expect a full name, so a name which basically contains a space. So let's say Jessica Davis here. And so now we can create a setter name, and then we need the name itself. And then here we need some logic. So to test if it contains a space, if the name includes a space, and I'm not sure if it is called includes actually. Now let me just test it here very quick. I have to comment out if it only. But if not, we want to give an alert. But what's in the property that we're in is going to be executed. Oh, it or here. Okay. To this weird error. So what we need to do instead is to here create a new property name. And the convention for doing that, so when we have a setter which is trying to set a property that does already exist, then here as a convention we add an underscore. So again, this is just a convention, it's not a JavaScript feature. So it's really just a different variable name to avoid that naming conflict. However, now when we do this, we are actually creating a new variable. So a full name variable. So let's try this now. A new variable. However, not different here, which is trying to set a property that does already exist, then here as a convention is trying, and the convention for doing that, so create to set the exact same property name. And so that gives origin to this weird error. So what we need to do instead is to here create a new exact same property name. This constructor function are trying to set the exact same property name. And so that gives origin to this weird error. So what we need to do instead is to here create a new property name. And the convention for doing that, so when we have a setter which is trying to set a property that does already exist, then here as a convention we add an underscore. So again, this is just a convention, it's not a JavaScript feature. So it's really just a different variable name to avoid that naming conflict. However, now when we do this, we are actually creating a new variable. So a full name variable. So let's try this now actually. So if we try to look at Jessica Davis, you see that right now the property that exists is underscore full name. And so right now we cannot do Jessica.full name because that simply doesn't exist. And so to fix this, we now also need to create a getter for the full name property. And so that will simply return the underscore full name. So let's see. So return this dot JavaScript feature. So it's really just a different variable name to avoid that naming conflict. However, now when we do this, we are actually creating a new variable. So a full name variable. So let's try this now actually. So if we try to look at Jessica Davis, you see that right now the property that exists is underscore full name. And so right now we cannot do JavaScript feature. So it's really just a different variable name to avoid that naming conflict. However, now when we do this, so when we have a setter which is trying to set a property that does already exist, then here as a convention we add an underscore. So again, this is just a convention. Now we got this crazy error here of maximum call stack size exceeded. Now that's a very cryptic error message, but what happens here is that there is a conflict. So right now both the setter function and this constructor function are trying to set the exact same property name. And so that gives origin to this weird error. So what we need to do instead is to here create a new property name. And the convention for doing that, So when we have a setter which is trying to set a property that does already exist, then here, as a convention, we add an underscore. So again, this is just a convention. It's not a JavaScript feature. So it's really just a different variable name to avoid that naming conflict. However, now when we do this, we are actually creating a new variable. So a full name variable. So let's try this now, actually. So if we try to look at Jessica Davis, you see that right now the property that exists is underscore full name. And so right now we cannot do Jessica.fullname because that simply doesn't exist. And so to fix this, we now also need to create a getter for the full name property. And so that will simply return the underscore full name. So let's see. So return this dot full name. And so if we try to do the same now, then you see that we are back to having this full name here. All right. And of course, the actual property that is here is now still underscore full name because, well, that's what we do here in the setter, right? But then we can also compute this full name pattern here is important to understand. Whenever we try to set a property, let's try another name here just to see what happens. So let person using innate this error. Oh, if we check out Walter, it probably doesn't have any name. And if we then put it as a full name, alter like this, then we get the underscore full name. But just like before, we can then also access walter.fullname because of that setter. Okay, great. So this is another nice feature of classes or setters, and many people actually don't. But yeah, as I just said, sometimes it's nice to be able to use. In this short video, let's quickly going to talk about static methods. Now, a good example to understand prompt. And for some reason it is empty. A method. Our constructor, so the array constructor, and not to the prototype property of the constructor. All right? And so therefore, all the arrays do not have array that's attached to the array constructor. And the reason for that is simply so that developers know that it is related to arrays. We also react the thing. And it's now let's quickly take this and do the same in the class where it is even easier. So here to create a static method. Now let's just take a look at the this keyword here. But this again should be pretty obvious. And so that's essentially the entire constructor function here. And the reason for that is because that is exactly the object that is calling the method. And so as always, that is basically the rule. So whatever object is calling the method will be the this keyword inside of that function. And so here that this keyword is simply that entire constructor function. Great. And now let's quickly take this and do the same in the class where it is even easier. So here to create a static method, all we need to do is to add the static keyword. So static hey, and then that's it. So let's just write that here is what we call it to the prototype property, so that all instance methods here at the end, hey, and to the entire class are not available on the instances about a class or about a constructor function. So we learned about constructor functions and ES6 classes, but there is actually a third way of implementing prototypal inheritance, or delegation, as we can also call it. And that third way is to use a function called object.create, which works in a pretty different way than constructor functions and classes work. Now, with object.create, there is still the idea of prototypal inheritance. However, there are no prototype properties involved, and also no constructor functions and no new operator. So instead, we can use object.create to essentially manually set the prototype of an object to any other object that we want. Okay, so if we can set the prototype to any object, let's actually create an object that we want to be the prototype of all the person objects. So essentially, let's recreate the person class from earlier. So let's say person, and then I'm calling it person proto, which stands for prototype, because again, this object is going to be literally the prototype of all the person objects. Okay, and now this is actually just a simple object literal. And so now what should we actually put in here? Well, we're going to put exactly what we put before into the prototype property. And so that was the callH method, right? So we did that actually here first manually. So we added callH to the prototype property of person. And then here we also did that, but in a more implicit way. So JavaScript did that for us behind the scenes. But now let's take this function here, or actually we can take all of this, because we can also write methods in this way in object literals. And so that's actually it. That's all the methods that we want the person objects to inherit. And so we put them in the prototype. And now all we need to do is to actually create a person object with this object here as the prototype. And for that, we can use object.create. So let's create a person called Steven here. And so now object.create. And here we pass in the object that we want to be the prototype of the new object. So that's person proto. And so this will now return a brand new object that is linked to the prototype that we passed in here. So Steven here is right now an empty object, and it will be linked to this person proto object, which will be its prototype. And we can actually already see that here in the console. So as I said, for now it is empty, but we already have the prototype, and in there we see we have called H. All right. But now we don't have any properties on the object yet. So let's quickly fix that. So Steven.name. So I'm doing it here just like I would do in any other object literal. And so this is not ideal, of course, but we're going to fix that in a minute. Because, of course, we want actually a programmatic way of creating new objects instead of having to do it like this. But again, for now, we are just worried about the prototypes and the prototype chain here. So we should now be able to say Steven.callH. And yeah, that worked. And so you see that we just like before implemented prototypal inheritance, but in a completely different way. And now, just to make sure that we're all on the same page here, let's make sure that we really understand this big difference. And so let's take a look at a diagram of what's really going on here. So here at the right side, we have the way it works with the constructor functions, just as we have been doing it up until this point. So when we use the new operator in constructor functions or classes, it automatically sets the prototype of the instances to the constructor's prototype property, right? So this happens automatically, and so that's nothing new at this point for you. Now, on the other hand, with objects.create, we can set the prototype of objects manually to any object that we want. And in this case, we manually set the prototype of the Steven object to the person proto object. And that's it. Now the two objects are effectively linked through the proto property, just like before. So now looking up properties or methods in a prototype chain works just like it worked in function constructors or classes. And so the prototype chain, in fact, looks exactly the same here. The big difference is that we didn't need any constructor function and also no prototype property at all to achieve the exact same thing. So this is actually a bit more straightforward and a bit more natural, and I guess that it might also be easier to understand. However, the reason why I'm showing you this object.create technique right at the end is because in practice, in the real world, this is actually the least used way. Very important to know exactly how object.create works, because you will still stumble upon this in the real world. And even more importantly, we will need object.create to link prototypes in the next lecture in order to implement inheritance between classes. So with that, we're going to take object-oriented programming to a whole new level, and the object.create function is going to be crucial in that, as we will see. I just said .delete the object that we specify, and that makes sense, right? Because here we said explicitly that person.proto should in fact be the prototype of Steven, right? And so therefore, right, because here, person proto. Yeah. So you see, this is exactly person proto. And that makes sense, right? Because here we said explicitly that person.proto should in fact be the prototype of Steven, right? And so therefore, this of course is going to be true, right? And it is. So now that we know exactly what's going on here, let's quickly create another person. So con.proto, this object is programmatic implemented. That this looks a bit like the constructor function that we created earlier, right? However, this has actually nothing to do with any constructor function, because we are not using the new operator to call this, right? And then we will pass, then use that just will explicitly from the constructor method. Here could be any name. And indeed, we could have a method like this in any other object literal. All right? So essentially, this is how object.create works. So, and the prototype of that object will be the object that we passed in. So that's what matters from this video. So over the last couple of lectures, we explored how prototypal inheritance works. works in JavaScript, and we did that using a couple of different techniques. So we use constructor functions, ES6 classes, and object.create. Now, all of these techniques basically allow objects to inherit methods from its prototype, so to delegate their behavior to their prototype, right? But now it's time to turn our attention to more real inheritance, so in the way that we learned in the very first lecture of this section. So what I'm talking about is real inheritance between classes, and not just prototypal inheritance between instances and a prototype property like we've been doing so far. And I'm using class terminology here because this simply makes it easier to understand what we're going to do. But of course, you already know that real classes do not exist in JavaScript. But anyway, here is what we're going to do. So we will create a new student class and make it inherit from the person class that we have been using so far. So person will be the parent class, and student will be the child class. That's because student is basically a subtype of a person. So a student is also a person, right? But it is a more specific person. And so this is an ideal child class. Now this is really useful because with this inheritance setup, we can have specific methods for the student, but then the student can also use generic person methods like the calc_age method that we have been using. And that's basically the idea of inheritance that we're going to implement in this lecture. Now just like before, we will start by implementing this using constructor functions. So in this lecture, we will inherit between classes using constructor functions. And this is going to be a bit of work, but it will allow you to understand exactly how we set up the prototype chain in order to allow inheritance between the prototype properties of two different constructor functions. Then in the next lecture, we're going to do the same thing using ES6 classes, which, as you would expect, is a lot easier. And finally, of course, we will go back to using object.create as well. All right, but enough talk, let's put this into practice now. So here I already have the person function constructor that we have been working with in the beginning of this section, and also the calc_age method that we set up on the prototype property of person. So this is just a copy of what we already did. And so now let's continue. So now usually we want a child class to have the same functionality as usually we pass in the same arguments, but then also some additional ones. So that's going to be again first name and birth here, and then we will also pass in the course. And so now everything works the same here. So first name is going to be first name, this dot birth year is birth year, and finally this dot course is going to be the course that gets into the function. So you see that in fact this student class here has kind of the same data as the person, so it also has the first name and the birth year, but then it has an additional property. Well, let's check here. Born in 2020 and indeed it. So we take the prototype property one more time, and then let's create a method called introduce. And so here we're simply going to log like an introduction phrase to the console. So for the student to introduce himself. So my name is this.first name, and I study, and then the name of the course. So let's call that here, Mike.introduce. And all right, so that works just fine. Great, so far so good. However, there is one thing that we can and should improve here in our student constructor function. So right now, this part of the code here is basically a simple copy of the person function constructor. So of this one that we want to be the parent class, right? And as you know, having duplicate code is never a good idea. First, because it violates the don't repeat yourself principle. And that change will not be reflected in, let's simply call the person function. So person, and then we pass in first name and the birth year as well. Now, do you think that this is going to work? Well, let's see, and then I'm going to explain you why this doesn't work. So the problem here is that we are now actually calling this person constructor function as a regular function call. So we are not using this new operator to call this person function constructor. And so therefore, this function call here is simply a regular function call. And remember that in a regular function call, the this keyword that it cannot set first name on undefined. So instead of simply calling cannot set first name on, so therefore that's why we get this error here that it cannot set first name on undefined. So instead of simply calling the person function here, we need to manually set the this keyword as well. So do you remember how we can call a function and at the same time set the this keyword inside that function? Well, we can simply use the call, but we will be able to specify the this keyword here as the first argument in this function. And so, in this case, we want the this keyword inside this function to simply be the this keyword. As you know, the this keyword is going to be in the beginning this empty object, the object where. So if we check this now, and more robust solution. Okay, so far, this is what we have built. So then the mic object linked to its prototype property. Now this link between instance and prototype has been made automatically by creating the mic object with the new operator. So all of this is what we had already learned. So this is nothing new at this point, right? Now a student...
Let's take a break.